right, welcome everyone to this session where we're going to be talking about configuring your PagerDuty account using Terraform. My name is Scott McAllister. I'm a developer advocate here at PagerDuty. I'm also the Terraform provider maintainer, which means I work with the code that makes Terraform work with PagerDuty, but I also work with other engineers that are helping as well. You can find me on Twitter at stmcallister, and I've left that throughout this presentation so that if you have any questions as you're going through this, you're thinking, oh wait, let me reach out to Scott. You'll see it down in the bottom right-hand corner. Now, the hope is today is that when you leave here, you'll understand a little bit more about how Terraform works, what it is essentially, and even how it operates with PagerDuty, what the code looks like, how to run it. Even going to give you some opportunities to go find projects that allows you to run it on your own machine so you can see how it would work with your PagerDuty accounts. Maybe some sandbox accounts so you're not using production, but we'll help you get started with using PagerDuty and Terraform together. Now, remember back to a time when you started something new, some new service or platform, something say like PagerDuty, and your team tested it out with a small group, small test case, and you got super excited about it, told your boss, she ran it up the chain, and it was like, wait, this is great. You saw the value it's going to provide the company, how productive you're going to be. And so she came back and brought you the great news that the company was going to adopt it and roll it out to everyone. Everyone high fives each other. If you're all on Zoom, you did that whole virtual high five thing. And your boss still just stood there smiling expectantly. And that's when I hit you. Your team are the ones that are the experts. Your team are the ones that are going to be rolling this thing out to everyone. You'll be onboarding all the users, the services, the escalation policies, the schedules, thinking about going through each of those different forms and wondering if you're going to type everything correctly or get all the configurations right honestly makes your head ache. But luckily, this problem isn't new. All of our infrastructures have become more and more complex as we rely on a variety of systems and services that make our applications and our companies operate. But all these services that we rely on also have APIs. And those APIs allow us to interact with them without going through those web forms. And so that's where the idea of infrastructure as code was born. Because folks realized, wait, I don't have to go through and type things into web forms. I can actually just code this thing, run a script, and it will work. Because I can keep everything managed just inside of my applications. And I'm inside of my application code. So with infrastructure as code, it's a principle or a practice, and not necessarily a product per se. It does provide a few of these promises. The first is that it's fast. If you think about running a script that has already defined your infrastructure, that's a whole lot faster than going through those web forms and waiting for things to load and wondering if you got things right. It's also consistent. When you have everything defined in one place, whether it's a file or maybe a group of files in a directory, you can see quickly how you have things defined. And you can keep things consistent all throughout your configurations and your definitions. With that, you can also reduce errors because your company has worked hard to reduce errors in your application code. Your application code isn't going to go to production without code reviews, without someone else checking out, okay, just want to make sure that this change is what we intend it to do. And no, I don't think it's going to have any adverse effects. So code reviews are vital. You can also have testing, some automated testing that goes into those changes before it goes live. And then every once in a while, you might need to go back and look at something that has created problems, but then you can look at the history because you'll have a history of all your infrastructure changes, and you can roll back to those different changes. You can also see when you look at the infrastructure as code that it's self-documenting. Everything is defined in one place. It's documented there. You don't have to wonder, wait, now where in that system do I go to find that setting to see if we have that right? It's all in the code there. You see it and you can have access to it. Anyone can have access to that and see the state of your system today. And then did I mention that it's fast? Not only is it fast at creating and changing things, but think about scaling. When you have a definition that you like, say when you start a new service and you add a team and a schedule and escalation policy to it, maybe you like that particular setup and you say, this we'll use every time we add a new service. And then suddenly as you scale, those repeated actions are easily defined right there in your Terraform code for you that you've already done. You've already done that work. Why do it again? Just have the code do it for you. So infrastructure as code in and of itself is a principle and a practice. There's lots of tools that actually do it. Terraform is one of them. AWS has CloudFormation. There's up-and-comers like Pulumi that provide a different slant on how to do infrastructure as code. But Terraform is really the out-and-out leader at this point in time, at least with our users. Our users love it. They tend to, every request that comes in about it seems to be about infrastructure as code, seems to be about Terraform. And so it's the leading one that we see here at PagerDuty. And so that's the one we talk about the most. But I'm going to talk about a few other reasons why it provides value to your operation. So to give you some background on Terraform, it's an open source tool provided by a company called HashiCorp. And HashiCorp provides it for the community. They also have other licenses, which are outside the scope of this talk. Totally go talk to HashiCorp if you want to find one of those. But the part that I love about Terraform is that it's declarative. Now, when something's declarative, it means you declare the definition right there. You just give it an object and you say, this is my object, here are my fields. Rather than imperative, which is where you give it a long list of instructions and say, set up this user, set the name to this, set the user or the email to that, set the address to that. So I love that it's declarative. And then with Terraform, you can build, update, delete all the resources in your system that you're using to manage with Terraform. And then once you start using Terraform, it's kind of the engine. It's the thing that is the source of truth. When you have that source of truth, you're going to start making your changes in Terraform because Terraform checks to see, is there a change between your definition and what's in PagerDuty? Well, then if there is, I'm going to push the definition through and make sure that PagerDuty matches my definition. To give you a real high level idea of how things are related in the Terraform world, HashiCorp essentially supports and maintains the Terraform engine. It's the infrastructure as code engine that does all the magic. How it connects to the different services, like PagerDuty, is through something called providers. And providers are usually either managed by companies that they're providing or by the community that use that product. And in our case, it's a little bit of both. There's a really active community of developers that are helping maintain the PagerDuty Terraform provider. In fact, it was started by a member of our community and maintained by him for a few years until we got involved. And now we support the Terraform provider as well inside the company. I'm one of those people, and we have other engineers who are committed to making sure that the Terraform provider stays up to date with our API, make sure that it works for you, also that it's efficient, and we try to make sure that the bugs are reduced as much as possible. As you get going with a provider, you'll find that the providers are listed in what's called the Terraform registry. And the Terraform registry is where you'll find our documentation. So if you go to terraform.io, you'll see and search for PagerDuty, you can find our documentation. You'll get very familiar with this, learning about all the different possibilities of what you can do, and just understanding how things work. And great examples. There's great examples in there as well. So let's go back to those promises of infrastructure as code as I was talking about. First, let's talk about how they relate to Terraform and how it's fast. We have a customer who needed to provision 2,000 new users, and they used Terraform to do it. They were able to get those 2,000 users added to PagerDuty in about 67 minutes. 67 minutes. If you do the math on that, that's about 2 users a second. Don't care how fast you type, that's fast, right? With all that definition, all those definitions you have there, that is something that's all running very quickly. Not only do they have those 2,000 users, they also had 6,000 other objects like schedules, escalation policies, services. They were able to get those added in about 90 minutes. So what? 2.5 hours, and they were able to provision 8,000 objects inside of PagerDuty. Not a bad use of time. Seeing how Terraform is consistent, it helps you keep your infrastructure consistent. It helps you understand how things are defined and how they're defined in relation to each other. In this case, we look at these definitions of these two services that we have, and we want to make sure that their names are consistent, because a good service, a well-defined service, is one that at least refers to that portion of the application that they're related to. In our case, we have these two services that are about the API and the database, and they both deal with the checkout process. And we want to make sure, okay, the checkout process is well defined. These are the services that are part of it. We want to make sure that we're following the principles of full service ownership and make sure that these services are well defined and consistent. We have that. We can see that in our Terraform code. We can see it in those definitions that we have here. When we start managing our infrastructure through code, we can take the same practices, the same principles that we're using to keep code quality in our application code and apply them to our infrastructure code. With that, we can adopt things like code reviews, like automated testing. That way we can do our infrastructure changes and understand, okay, I have an assurance that when we make these changes, I can feel safe that these changes are not going to hurt my system. They're not going to have adverse effects. Yeah, but like application code, we all know that sometimes things actually just make their way through. And so if we do see a divergence between what you want, what your planned infrastructure is, and what the infrastructure currently is today, we see a divergence there, we can look at that commit history. Keeping your infrastructure code in a version control system, just like you keep your application code, you now have a complete history of all the changes you've made throughout time. And you can roll back and say, wait, this is where the divergence happened. Let's drill into that commit. Let's see what's happening there. Ah, I see. And when we started messing with the schedule here, it looks like Mr. McAllister made a commit that changed the schedule. And that's when the schedule started behaving poorly. Let's either roll back to a previous commit before this, or let's go talk to Scott and say, wait, why'd you do that? We wanted it to do this. And then you can have that conversation. But you can make sure that you can get any adverse effects fixed quickly. Now, on the point of self-documenting, I wanted to show a little bit more code to show that your application and your system is defined with this code so that your infrastructure you can easily take a glance at it and say, I see now. I see that the state of my system at this point in time is this. My services are defined this way. We saw that code earlier on the left. And then we can see that we have these service integrations that are defined down the right. These services are connected to CloudWatch and Datadog. Ah, okay, that's good. And all right, these are the settings for that. All right, that's good. This is all self-documenting. I can see where those changes are or where those settings are set in our system. Now let's drill down a little bit into the Terraform code. Terraform code, officially, if you want to sound smart at parties, is HashiCorp Configuration Language, or known as HCL. HCL has a few different common blocks that I want to show you before you get started. The first is the resource block. This resource block is identified by that resource keyword in the upper left. And then a resource essentially is telling the Terraform engine, okay, everything defined in this block, you're going to manage. We're going to create it if it doesn't exist. If it does exist, but the definition is different here than it is there, let's make a change. Or if the definition's gone, then it's going to take it out of PagerDuty. When you have a resource block, it has a resource type. That resource type is defined by the name of the provider _, and then the name of the object. The reason why it's important to point that out is because you can define more than just PagerDuty in your code. You can define all sorts of pieces of your infrastructure. And so making sure that Terraform understands this is with the PagerDuty user, not with your Datadog user, not with your Amazon user. So you make sure that you identify which provider you're trying to use. With each of your resources, they each have a unique identifier. In this case, Lisa lets the rest of the Terraform code know if you want to get into any of these fields, any of these properties, then you'll need to use the word Lisa to help me understand which information you're trying to get at. So in our case, if we wanted to reference Lisa's information, we would say PagerDuty _user.Lisa and then .id. that would grab Lisa's ID out of her user object. And then with that ID, we can use it to set her, or to put her in like a schedule or something, or into some other object that needs a user ID throughout the Terraform code. Now, sometimes we have resources that are already in PagerDuty, right? In this case, Susan is the owner of this PagerDuty account. And so as the owner, she's not going to be added to the account through the API or through Terraform. But we do still need to get Susan's information. Sometimes we want to add Susan to a schedule. And so what we need to use is what's called a data source. And this data source, denoted by the little data keyword there on the left, is essentially, I think of them as a query object. And that query object uses whatever value is the unique identifier for that object. So in this case, a user is uniquely identified by an email. And so it takes that email address and then passes it to PagerDuty and says, I'm looking for a user with this email address. Could you grab that for me? And then when it does, you can have that object available to you so that you can add Susan to other objects like schedules and escalation policies. The only difference is you just say data dot PagerDuty_user.Susan.id. That tells Terraform, all right, this is when we're trying to get information out of the data source rather than out of just a regular resource. The final object or block that I want to point out is the Terraform block. The Terraform block is where we define all of the required providers that we're going to be using in our definitions. So in our case, today, we're talking about PagerDuty. So this is the PagerDuty provider that we're grabbing. And we're even getting the value or the version so that we can get, the current version of the provider, which at the time of this recording, 2.4.0. And that way it gets you that version of the provider. And you know which features are supported, which fields are there, just by going to a specific version of that provider. So the workflow that happens when you are using Terraform is you as a practitioner, you write that Terraform code, that HCL that we were looking at just very briefly. You type that up as infrastructure as code. And then when you're ready, you plan it, which is a command that we'll talk about, which actually takes the Terraform code and compares it to PagerDuty and says, are you sure you want to do this? And then when you're ready, you apply it. And when you apply that Terraform code, it takes it and it passes it to the various providers. Any number of variety of providers. In this case, we could be setting up PagerDuty with some Azure and maybe some Kubernetes. And then all of those providers will be in play, and then they'll be touching their different systems and hitting those APIs. That way we can actually take those settings and make them happen on those different systems. When you're getting ready to use Terraform, there's 3 commands that I want to talk about. The first is Terraform init. So in the command line, you will type Terraform space init. And what that does is in the directory that you have your Terraform file, it will take the definition that you have in that Terraform block, and it will download all those required providers that you have defined. All of those providers, it will bring the binary actually down to your system and use them locally to make all the API calls and all the changes for you. Then when you're ready, after running Terraform init, you'll run that plan. Plan is going to take the definitions and actually hit the APIs. It will hit them, and it won't make the new users. It won't commit the changes. It's just essentially scouting things out and saying, okay, here's the definition that you have in your file. Here's the state of what's in PagerDuty today. Now I see here are the 2 different things, or here's the 2 different definitions, or the changes that need to happen. Here's what needs to be added. Here's what needs to be changed. And it looks a little something like this, where you have this output in your terminal that shows you, all right, in this case, we have 2 users. They're defined. They're new. We have Bart and Lisa. Here are their different fields. Here are their different values that we're going to be, or their properties that we'll be setting inside of PagerDuty. And are you sure this is good? If you like it, then it's ready to apply to your system. And that takes us to our third command. With Terraform apply, it does that Terraform plan, because Terraform definitely understands that when you're running Terraform, you could be spinning up objects that could be costing you money. So they really want to make sure, is this something that you want to be doing? So they run that plan again, and they let you know, okay, with that Terraform apply, it will take that change and it will make it so that it says, all right, here's the plan. Are you sure you want to do it? Yes. You type the word yes. And then when you make that change, or when you type yes, it takes those changes and commits them. It applies them to your system, creates the users, updates the users. If you remove it from the definitions, it deletes the users. So that's what Terraform apply does. And then it looks a little bit something like this, where the output shows you just a real brief definition of, okay, here's a log of, here's this user. It took it a second to create it. Here's its ID. These things were added. Nothing was changed. Nothing was deleted. All is well. So there was a whirlwind introduction to a few things that you'll get going in using Terraform. The different resource blocks that you'll see in the code, and then the 3 different commands that you'll be using. To take your journey one step further, here are some resources that'll help you in your exploration. The first is a blog post that we wrote about the how and the why of Terraform with PagerDuty. This gives you another overview of how things work, shows you some code, gives you a sense to see how things work and how things are written down. Then I invite you to build or create a PagerDuty developer account. Now, developer accounts are available at developer.pagerduty.com. There's a little green sign up or get started button in the upper right. You can also just go to /signup if you'd like. These accounts don't expire. And so they have a limitation of 3 users. They also can't send out SMS. But the idea is you can try things out. You can try things out with Terraform and understand how it works, how it affects that system without messing with your production data. And then to populate that developer account, there's a project on GitHub called PD Populate Dev Account. This project has Terraform code in it that will set up some users, a team, adds those users to a team, creates a schedule, an escalation policy, even some services, some service integrations, some event rules even. All that's there defined in the Terraform code. So you can look at the Terraform code, understand how it's defined, run it against that developer account, and then make changes to that Terraform code. See what's going on. See how when you make changes, how does that affect your system? How does that look in Terraform when you try to maybe add a different type of object or change a field on an object? That way you can start exploring yourself. And then finally, there's that Terraform documentation that you can find in the Terraform registry there at HashiCorp, or on HashiCorp's website at terraform.io. So that's the action item that I recommend that you take, is create that developer account at developer.pagerduty.com. Go find that project for populating that dev account and has the Terraform code in it, and then run that Terraform code to see how it affects your system and then how you can get going with Terraform and PagerDuty today. Thank you all for joining me, and I wish you all the best in terraforming with PagerDuty.